We'd like to investigate the interval of convergence of the non-power series cosine of k to the third times x over k squared. Non-power because x is not raised to increasing powers, right? So as k increases, notice that x is not raised to the kth power. But in any case, we want to find uh, the interval of convergence of this non-power series and also the interval of convergence of the derivatives, of the series of derivatives, okay, of this non-power series. So let's say, so first, notice that we want to test this for absolute convergence, right? So we want to test this for absolute convergence. So we take the absolute value of the k to the third times x over k squared. Okay, so notice first of all that cosine, the absolute value of the cosine of k to the third times x divided by k squared is less than or equal to 1 over k squared, right? Because cosine, by definition, the absolute value of the cosine k to the third x is less than or equal to 1, right? So dividing both sides by k squared gives us this result. Now we know that the series of 1 over k squared is convergent, right? It's a convergent p-series, right? Because the p-value here is 2, right? That's greater than 1. That's why it's convergent. Now, since we have a larger series convergent, then the smaller one must be convergent as well, right? So this is convergent. So that means the original one without the absolute value, since we just tested for absolute convergence, this one without the absolute value bars must be convergent for all x, right? So the interval is going to be negative infinity to infinity. Okay, so now we're gonna differentiate this, and we're gonna find the interval of convergence of the series of derivatives of the non-power series, right? So differentiating from k is equal to 1 to infinity, we will take the derivative of this, right? Taking the derivative gives us what? Gives us a negative sign, of course, because we will have a negative sign there. So there's a negative sign outside from 1 to infinity. So we will have also k to the third coming outside, right? Because that's the constant of x, right? Because that when we differentiate the inside, first we differentiate the cosine, we get negative sign, right? So sine k to the third x, and then the inside differentiation makes the k to the third come out. That's why it becomes a constant multiplying the sign, right? But in any case, what happens to this? And k squared is a constant that stays there, right? So what happens to this? This is the series of derivatives, right? We just differentiate this. What happens to it? What happens to it is that, well, we can actually simplify this, right? The negative sign outside, we can simplify this as k sine k to the third x, right? Because the k to the third divided by k squared is k, right? And this minus sign is not going to make a difference because if we take the limit as k approaches infinity of this, of k sine k to the third x, we know that it's going to be 0 if x is equal to 0, right? Because x is equal to 0, we'll make sure that that the 0 will be the angle of the sign, right? That sine of 0 is 0, right? So there's a convergence value of 0 when x is equal to 0, no matter what the k value will be, right? But you have to be even more careful. You can't just say x is equal to 0 um, Actually, x is not just 0, right? So we have to account for all types. We have to count all types. Uh, we have to count not only 0 but also pi, 2 pi, 3 pi, and so on and so on. So we will indicate this as n pi, right? And n integer. So this accounts for n being -1. In that case, it's going to be pi. N is equal to 0 will make x equal to 0. N is equal to 1 will make it pi, and so on and so on. Multiples of pi, both plus and minus, right? So this is great, right? So 0 when x is equal to n pi, n being an integer. Now diverges when x is not equal to n pi, right? Because k will be, if you take k to infinity, it will simply diverge, right? Because other x values will not make sign of 0 and will not make this x values that are not n pi and n being an integer will not make sign of 0, right? So that means and that k to the third will also make the non-multiples of pi for the x values different values of the sign, right? In any case, there is no convergent value because sign will always fluctuate, right? For other values of x that are not part of that solution, the sign will always fluctuate, right? And the k will make the sign bigger, 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 and bigger and bigger waves, right? Forever. So there's no convergence anywhere. So there's divergence when x is not equal to n pi. Okay, so the only solution, convergence interval here, is simply one x value, right? Well, not just one x value, but many, infinitely many x values, n pi, right? N integer. Thank you so much for watching, and see you in the next video.